Hello everyone, it's been quite a while since the last video in this series. Now this is number 11 and the question is briefly explain artificial intelligence quantization, AI quantization. In simple terms, quantization refers to the process of reducing the precision of numerical values within a neural network. Here we can see a simple neural network. We have input layer, output layer and some hidden layers, and the nodes, the neurons in this structure are connected with each other. I just draw some of them, but they are all fully connected. And remember, all of these connections has some weights. So basically the quantization involves representing values with fewer bits, which also can lead to more efficient computation and reduced memory usage. So how? Okay, imagine these nodes. Let's assume that we have 3 nodes here and 1 node here, so we have 3 connections, right? Just ignore the bias. And so we have 3 weights, and these are floating points. And when we implement quantization, we can reduce this precision. We can convert these floating points into integers. For example, here, instead of 0.234, we can write 0, here 1, and 3. Just integer numbers instead of floating points. But what does it mean? Why it is important in terms of optimization, memory usage? Okay, if you look at this diagram, you can see that one single precision floating point requires 32 bits in the memory. However, as you see, when we reduce the precision or when we convert this floating point to integer, instead of 30 bits, we can just use 8 bits in the memory. And imagine all multiplication operations, millions of parameters. So from 32 bits to 8 bits will mean a lot when you have 1 million parameters, okay? And the recent neural networks contain millions, even billions of parameters. So that's an important step in terms of optimization. And the quantization step is quite important and crucial, especially when working with resource-constrained environments, such as edge devices or embedded systems. You can imagine wireless communication, satellites. You need to optimize resource usage, right? And the quantization allows us to strike a balance between maintaining model accuracy and optimizing performance. One of the primary advantages is improved inference speed. Okay? By reducing the precision of weights and activations, computations can be performed more quickly and resulting in faster predictions. And obviously, quantization helps in reducing the model size. Okay? As we decrease the number of bits, then the overall memory footprint of the model decreases, right? Okay, now let's look at some best practices of AI quantization. And first of all, you should be careful about precision selection. You should select the precision wisely. There are different techniques and they affect the performance of the model and the optimization progress, okay? And secondly, of course, the data set should be large, big enough, sufficient, and also the representative. And naturally, the quantization will decrease the accuracy of the model. Therefore, after quantization, fine-tuning model will be helpful to increase the accuracy, to increase the performance of the model. And lastly, you should monitor the model and the model performance measures like accuracy. Of course, there are more best practices, but these are just the fundamental ones. And there are different approaches in the quantization like post-training quantization and quantization-aware training. So I will not go deeper now, I will not go details. But if you are interested in this topic and if you want to check the details, I can suggest some sources. For example, so there is a good medium paper from Jean, the Master of the Art of the Quantization, a Practical Guide. You can check it, it's quite helpful. It also contains some TensorFlow and PyTorch examples, as you see here. Or you can directly go to the tutorials of TensorFlow Lite, for example, the post-training quantization, okay, the methods, the overview, the examples, what is full integer quantization, dynamic range quantization, you can check it. Or there is a comprehensive survey paper about quantization methods. It's a bit long, but there are very good details and information in this paper. You can check what is uniform quantization, symmetric quantization, and quantization, granularity, dynamic and static. They explained them, and it's a very comprehensive paper. Okay, that's all for this video. Thank you very much for the watching. See you in the other videos.